So now we have moved to the last aspect of the chapter, that is called spontaneity. Okay. And in the initial class, in the introduction part of thermodynamics, I said, say with the help of certain concepts you can able to decide whether a reaction difficult or easy, possible or not possible, yes or no. Say this is the concept on which you can always say whether a reaction is easier type or not. Say if a reaction is easy, it can happen on its own, yes or no, you no need to struggle too much. But if a reaction is difficult, you need to provide lot of sources from outside. Say mainly you need to provide certain amount of energy from outside for making a reaction to happen. So those reactions are always difficult. Okay. So this idea you should have before you conduct any chemical reaction. Okay. So you must know whether a reaction is easy or difficult. And how do you decide that? You will decide it based on spontaneity. Okay. So that is what we are going to study now. You have certain kind of reactions in our nature which we call them as spontaneous reactions. Okay. So what do you mean by spontaneous reaction? The reaction that can occur on its own without any external help. Okay, without any external help. Okay, easy type of reaction. Can you all tell me the spontaneous processes that you will observe in a day-to-day life? You know, see, hot tea getting cold, it's a spontaneous process. Hot tea is there, if you keep it as such, you know, after some time if you come and observe, it becomes cool automatically. You are not struggling here, yes or no? To make it cool, you are not struggling anymore, it is becoming on its own, yes or no? So this is a spontaneous reaction. And the flowing of waterfall, how does it flow from top to bottom? It happens on its own. See, nobody is there behind to push the water to go down, yes or no? It happens on its own. So this is a spontaneous reaction. So in chemical reactions also, the moment you add two substances, automatically if you get the products, you know, such reactions are called spontaneous reactions. Okay. On adding the reactants itself, you know, you can easily get the product without any much work, without any external help, without any help of energy. Okay. So such reactions are spontaneous. In a similar way, we have certain reactions called non-spontaneous also. So what do you mean by non-spontaneous reaction? The reactions that does not occur on its own, okay, is called non-spontaneous reaction. Say for example, cold tea to become hot. Imagine the tea has become cold. If you want to make it hot, you have to work. Definitely, you should take the tea and keep it on a stove. With the help of energy only, it can become hot. If you leave the cold tea as it is to become hot, it's not possible. Where some external help is definitely necessary for the process to happen, isn't it? So such a process or such a reactions, you know, these are difficult type of reactions. If A and B on combining, easily you don't get C and D. You must provide lot of work from outside. You are supposed to do lot of work on them in the form of energy. Only then they can combine to produce the product. Okay. Such reactions are called non-spontaneous reaction. Okay. Understood? Spontaneous and non-spontaneous. Now the big question is, how do you decide? How do you decide the spontaneity? How do you decide which is a spontaneous reaction and which is a non-spontaneous reaction? Spontaneity. Yes? How do you decide? You must have some concept, isn't it? You must have some condition. So, those conditions we are learning one by one. Okay? Say first and foremost, they thought that enthalpy as a criteria to decide the spontaneity. That means by looking at enthalpy value, reaction enthalpy value, you can able to tell whether a reaction is spontaneous or not. That means enthalpy value will help us to decide whether a reaction can occur on its own or whether a reaction that does not occur on its own. Okay. Say what they decided was, what scientists decided was, if enthalpy of a reaction is negative, okay, if enthalpy of a reaction is negative, then those reactions are spontaneous, they thought. Okay, whichever reaction has a negative delta RH value, okay, negative delta RH value in the sense what type of reactions are there? Exothermic reactions. Yes or no? Only for exothermic reactions you will find negative delta H. So, whenever you have negative delta H value, they thought that the reaction is spontaneous. Okay? And whenever delta H value is positive, then the reaction will be non-spontaneous. Okay? Positive delta H value in the sense what? Endothermic reactions. So, this was the condition they created based on the experiments. Okay? They simply did not tell this, it is purely based on the experiments. Okay? And let us see few examples here. Say for example, formation of water, H2 plus O2. Okay? On combining you would get H2O. Okay, how do you balance this? Half O2. And can you able to remember the enthalpy of this reaction? Here the enthalpy is minus 293 kilojoule per mole. Okay, can you able to tell me whether this reaction is spontaneous or not? Definitely spontaneous. Why? Because it is a exothermic reaction. How do you say that it is exothermic reaction? Looking at the value of delta H, minus is there. Yes or no? Say whenever a heat is released during a reaction, heat released in the sense what? Some stable compound is getting formed. Okay? Say in our nature, all the reactions are in a process to form a stable compound, are in a process to become stable. Okay? So, hydrogen in this particular state may not be stable, oxygen in this state may not be stable. So, they are trying to combine with each other to form a stable compound called water. Okay. Say the reaction is proceeding towards the stability, energy is getting decreased. Okay. Whenever you observe stability in a reaction, energy will get decreased. Okay. Say decreased or energy released, that is why this is called exothermic reaction. Okay. You no need to struggle, it can occur on its own because a stable compound is getting formed here. Okay. So, we say for whichever reaction enthalpy is negative, maybe that is spontaneous. Okay. Say another more example here, N2 plus H2 may combine to give NH3, right. Say even this reaction's enthalpy is also negative, that is 48 kilojoule per mole. Okay. So, looking at the delta H value, I can say this is a spontaneous reaction. Okay. But there is a problem here. Okay. The problem is there is a reaction called carbon plus sulfur giving CH2. Okay. This reaction's enthalpy is positive, it is not negative, positive, but still it is spontaneous. but still practically we can prove that this is a spontaneous reaction. That means you no need to struggle for conducting this reaction. No energy is required from outside. It can automatically happen on its own. But what is its delta H value? It will be positive value. Okay. And similarly, ice melts into water. Yes. Do you have to struggle for ice melting into water? No, right? Ice, you keep it in a room temperature, automatically it gets melted. You are not supplying any external energy for making ice getting melted into water, isn't it? See, the process is happening on its own. But for this conversion, the enthalpy is, do you remember? I gave you this value, 6 kilojoule per mole. The energy involved in this case is called enthalpy of fusion. Okay, what is enthalpy of fusion? 6 kilojoule per mole. Okay, so this is endothermic. You see the positive value for delta H. Okay, but still it is spontaneous. Still it is spontaneous. Yes or no? Okay, that means whatever the conclusion that was there based on the experiments, that is, if delta H negative, we said it as spontaneous. If delta H positive for any reaction, we said it as non-spontaneous. But this is not true in all the cases. There are some exceptions. Okay, there are some exceptions. These guys, not only these two, many reactions are there which are spontaneous though their enthalpy value is positive. Many physical processes are there which are spontaneous though their enthalpy value is positive. Okay. So what they thought was, enthalpy itself is not enough to decide the spontaneity. Okay. See, listen carefully. Based on these reactions and explanation, what we can conclude is enthalpy value itself is not enough to judge the spontaneity of a reaction. Yes or no? Because you have these proofs in front of you. They have positive delta H but still spontaneous. So you cannot only depend on enthalpy value. So there came a new term called entropy. Okay, there came a new term called entropy. Okay, and which is denoted with the letter S. So what is this entropy? Entropy is nothing but degree of randomness or disorderness is called entropy. Okay. So what do you mean by this degree of disorderness or randomness? It was thought that every natural process that can occur on its own is associated with certain disorderness. Okay, got to know? Say for example, we have a class where 50 members are there in a class. As long as the teacher is there in a class, you all will sit in a particular places in your bench in an orderly manner. Yes or no? But once a teacher goes outside, do you sit in the same orderly manner? No, you keep moving here and there. That means disorderness has been increased. You keep moving randomly, that means randomness has increased. Okay, that itself we call it as entropy. Okay, so what I say, as long as the teacher is there inside the class, entropy is very less. That means there is no disorderness. Everybody are sitting very perfectly in an orderly way. The moment a teacher goes outside, entropy of a class is increased. Means what? The disorderness of a class is increased. The randomness has increased. Got to know? So the disturbance or disorderness created during a reaction or during a process is called as entropy. Okay, is called as entropy. And this is also a deciding factor for a reaction to be spontaneous or not? Usually, if entropy, say entropy is also a state function, it is also a state function, okay, just like enthalpy and internal energy, entropy is also a state function, and entropy is also, you know, extensive property, it depends on, you know, the amount of matter that is present within a system, okay. And since it is a state function, what do you mean by a state function? The property which can depend only on a state of a function, not on a path, okay. It depends on initial state and final state, so we always concentrate the change in the property. So we always concentrate here about delta S, okay. So delta S is equal to S2 minus S1, means entropy of a final state minus entropy of a initial state, okay. So we always use this particular term delta S. We bother about change in entropy, because for a particular system, if you want to calculate total amount of disorderness present in that in a particular time is impossible, okay. But you can measure the change, that's why we always concentrate about change in entropy, okay, fine. And if you want to tell whether a process is spontaneous or not, okay, entropy can also help us. What was decided is that if delta S value is positive, okay, then the reaction is said to be spontaneous, okay. Delta S value positive means what? If entropy increases during a chemical reaction, if entropy increases during a chemical reaction, then it is said to be spontaneous reaction, okay. And if entropy value is negative here, negative in the sense what? If entropy decreases, randomness decreases in a particular reaction or process, then that process or reaction is said to be non-spontaneous, okay. So you can observe this, I can connect it to a real life situation also. Imagine waterfall is falling from top to bottom, okay. If you observe the waterfall from top, you know, at the top when you observe, the water would flow in an orderly manner, okay. But as long as the water reaches down, you know, water keeps on spreading, that means disorderness is increasing. See, all natural processes are associated with certain disorderness. Say for example, if I want to make you all sit in an orderly way, I need to use my energy, I need to shout at you, then only you will sit at your places in an orderly way. But to make you in a disorderly way, say if you want to move it in a random way, you know, I no need to struggle too much, just if I can go out, your disorderness automatically increases in a class. Yes or no? So this is a slight proof that any natural process that can occur on its own is always associated with increase in entropy, okay. That means the disorderness may increase during a process. That is why it is said that if delta S is positive, the reaction can be spontaneous, and if delta S is negative, the reaction is non-spontaneous. Actually, there is a formula for entropy, that is delta S is equal to Q divided by T, okay. Say always entropy is directly proportional to the heat of a system. More heat if you observe in a system, definitely more disorderness. Say if you take a gaseous system, imagine you are heating it, you are supplying some amount of heat, automatically the gas would move more disorderly, yes or no? More randomly it will move, that means entropy will always increase. So change in entropy is directly proportional to the heat given to the system, okay, and it is inversely proportional to the temperature. Usually when the overall temperature is lesser, you will observe higher entropy. When the overall temperature is higher, you will observe lesser entropy change, okay. So in other words, I can also write it as delta S is equal to any enthalpy, that is delta H, change in enthalpy, and temperature. Okay, so usually this is a formula which we will use to calculate the entropy change. Okay, say on calculating, if you get a positive value, we say it as spontaneous. If you get a negative value, we say it as non-spontaneous. Okay, so this is all about entropy. Okay, say this is also a condition for telling spontaneity. Delta H can also tell about spontaneity, but you know you have a problem with delta H. Some of the reactions which were endothermic were also were spontaneous. That's the reason we went for the new term, that is delta S. Okay, so and finally we reached at this condition. But actually speaking, you cannot tell about spontaneity only based on enthalpy. You cannot tell about spontaneity only based on entropy value also. Actually, we have to combine both the values and then talk about the spontaneity. And that new term which includes the combination of the two factors is called Gibbs energy or Gibbs free energy. And coming to Gibbs free energy, okay, it's a very new term for you all again, indicated with a letter G here. See, as I already told you, the Gibbs free energy is a combination of both enthalpy as well as entropy. Okay, so there is an equation, that is G is equal to H minus Ts. Okay, so what is H here? Enthalpy. And what is S here? Entropy. Okay, and this is your important equation, and this equation we will call it as Gibbs equation. We can call it as Gibbs equation. And this G is also a state function, that means it will depend on initial and final state. So delta G is what we use it. Okay, and this is also an extensive property. See, normally speaking, when enthalpy and entropy both are state functions, automatically G also will be a state function only. Okay, when both are extensive property, G is also extensive property itself. So what actually we can write is delta G is equal to delta H minus T delta S. Their changes only we concentrate, because exact values of these guys we cannot calculate, no. We can observe only the change in Gibbs energy, change in enthalpy and change in entropy is what can be observed during a reaction. Okay, so I can write Gibbs equation as this also. This is what we prominently use it in chemistry. Okay, very important equation where every time you keep using this from now onwards. Okay, so what is delta G? Change in Gibbs energy. Change in Gibbs energy. Gibbs energy. Okay, this is what? Change in enthalpy. Change in enthalpy. And delta S is change in entropy. Change in entropy. Okay, fine. And now, actually speaking, this is called as free energy. The reason for calling free energy I am going to tell you. See here, you all know what do you mean by delta H, isn't it? Delta H in the sense what? Total enthalpy is nothing but total heat content of a system. Okay, total change in the heat content of a system is called enthalpy. Okay, and among the total energy present in a system, the whole of the energy will not be used to do a useful work. Here, what do you mean by useful work? To undergo a reaction. Okay, say for example, I have a beaker where I took A and B reactants. Okay, so it would have some heat content. It would have some heat content already. Okay, say if a reaction is using this heat content, okay, to undergo a change, then we can say this is actually a spontaneous reaction. Yes or no? Actually, among the total heat content, the total amount is not available for doing a work. For doing a work in the sense for a reaction to occur. Okay. only some amount of heat is available to do a useful work. Okay. Little amount of heat will go in waste. Little amount of heat will go in waste. Okay. It is not at all helpful for us, okay, to conduct a chemical reaction, to proceed a chemical reaction here. Got to know? So that wasted heat is what this term. Among the total heat, this much amount of heat is getting wasted. We can't use that heat. Okay. And remaining amount of heat itself we call it as Gibbs energy. And that heat is freely available for us. Okay. Say if a reaction can able to use that available small amount of heat, then we can say the reaction is spontaneous. Understood? Okay. So already some amount of heat would be there in a system, but the total amount is not available for reaction to occur. In that, some amount will go in waste. What is that amount of heat that is going waste? This much amount actually. T delta S of heat is getting wasted. Okay. And the remaining amount of heat itself, the remaining amount of free energy available in a system itself is called as, you know, Gibbs free energy. Okay. So if that Gibbs free energy is very less, with that lesser amount of energy only the reaction is getting proceeded to form products, then such reactions are spontaneous. Yes or no? So if the available energy is not sufficient, if you are providing externally some energy, say lot of energy is required to form a product, then such reactions are always categorized as non-spontaneous, isn't it? So based on this, what has concluded is, if delta G is negative, okay, if the Gibbs free energy is negative in the sense with little amount of energy itself, the reaction is getting proceeded or the products have formed, then such reaction is said to be spontaneous. Okay. So that is why if delta G is negative, we can say that the reaction is spontaneous. Okay. This is a very important condition that you have to remember. If delta G is positive, then we say the reaction is non-spontaneous. Okay. So whenever you see delta G negative, with little of energy itself the reaction is proceeding easily to form a product, you know, that means the delta G negative, then we say that reaction is spontaneous. If delta G is positive, the reaction is non-spontaneous. Okay. So this is the main condition we have to remember. So how do you know that whether a delta G negative or positive? You know, you can always calculate it by Gibbs free energy equation. Okay. If they give you this value, change in entropy value, then you can easily calculate delta G and you can decide whether you are getting a negative sign or positive sign. If you are getting negative sign, this is the condition. If you are getting a positive sign, this is the condition. Okay. So this is all about the spontaneity. Okay. And now just try to remember one small table when a reaction can be spontaneous or not. That means when do you get delta G value negative or positive. Okay. Let us see, I will make 3 columns here, delta H, delta S and delta G. Okay. See, whenever delta H is negative and delta S is positive, I'll write the Gibbs equation here. Delta G is equal to delta H minus T delta S. Okay. Say logically you apply the signs in the equation. What I said, whenever delta H is negative, if this is a negative value, okay, if delta H is a negative value and whenever delta S is a positive value, then final answer will be some negative only, no? Final answer you will get a negative value, definitely you will get delta G negative value as a final answer. So whenever you get delta G negative, what does it mean? The reaction is spontaneous. Reaction is spontaneous. Okay. And whenever this is positive and this is negative, then what value of delta G that you can get? See here, delta H positive and delta S minus of delta S value if I take negative, then final answer would be minus into minus plus some positive value only I will get. Okay. So, delta G will be positive, then the reaction is non-spontaneous at all temperatures. Okay, at all temperatures. And now, if both are negative, what will happen? If both are negative, see, delta H minus T delta S, isn't it? If this is also negative, okay, minus of this is also negative, what actually you will get? Minus into minus plus. See, whenever this value is greater, you know, you will get a positive value. Yes or no? When do you get this value greater? When you have temperature very much higher. Yes or no? Usually when does this value will be greater? When you have temperature much higher. Okay. So, when both are negative, you will get positive value for delta G at high temperatures. Okay, this is possible. Positive value can be possible only at high temperatures. When you get positive value, it means that the reaction is non-spontaneous. Okay. And you know, in this case, if this value is lesser, positive value is lesser, negative value is higher, then the answer is negative, no? Yes or no? When do you get this value lesser? When the temperature is less. So, here temperature plays a deciding role. Yes or no? Temperature decides whether you get delta G positive or negative. Okay. See, when both are negative, you can get negative value at low temperature. So, the moment you get negative value, what does it mean? The reaction can be spontaneous. It can be spontaneous. Okay. And now, if both the values are positive, what will happen? See, this is also positive value and T, this is also positive value. So, what do you get, guys? Plus, minus into plus, minus. If you want to get a negative value, this must be higher, no? This must be higher value. When do you get this value higher? When the temperature is very much higher. Yes or no? Okay. So, what I can write here? When both are positive, I can get a negative value when at high temperature. Okay. Say if delta G is negative, I can say the reaction is spontaneous. Okay. And now, when both are positive, I can also get positive value. Both are positive, I can also get positive value when this value is higher. When my positive value, that is delta H value, is higher. Okay. So, when do I get this value higher? When this value is lower. When do I get this value lower? When temperature is low. Yes or no? So, I can get a positive value here when both are positive at low temperatures. Okay. So, this implies when you have a positive delta G, it means the reaction is non-spontaneous. Okay. So, this is actually the effect of temperature. On delta G value. Okay. Say depending on the temperature, you will get negative sometimes, positive sometimes. Okay. Anyway, the most important thing that you have to remember is this condition. Okay, just stick it to this condition. If delta G is negative, the reaction is spontaneous. If delta G is positive, the reaction is non-spontaneous. Okay, so this is the ultimate criteria which is there in front of us to tell whether a reaction is easy type or difficult type. That means spontaneous or non-spontaneous. So this is all about spontaneity, and this completes our chapter thermodynamics and thermochemistry.